Okay, yes, we will take one more example. Let us say x of t is a rectangular function. Okay, so our x of t is a rectangular function, let's say from 0 to capital T. Will this satisfy the given condition here? What is the condition? X of t should be of finite duration, which is the case, and x of t should be absolutely integrable, and you can easily prove that this fellow is absolutely integrable. Okay, so what will be the corresponding x of s? So this would be equal to integral 0 to t 1 multiplied with e power minus st dt. So this should be equal to e power minus st by minus s with integral limits to be 0 and t. So that should be equal to 1 minus e power minus st divided by s. Okay, so that's okay. So what would be ROC? What would be ROC here? Yes, because we assume t to be positive. What would be ROC? You may be tempted to say that what? ROC is what? You should exclude S equal to, yes, you should exclude S equal to which one? Plus S equal to minus infinity. But what happens if you replace S with minus infinity? This fellow will blow up. Okay, if you replace S with minus infinity, if you replace S with minus infinity, this fellow will blow up. So definitely what is ROC? ROC is entire S plane. Okay, entire S plane, because you can easily do the L'Hospital rule and you can prove that this fellow is again finite even at large values of S. Okay, right. Okay, so indirectly it means what? If x of t is of finite duration and if it is absolutely integrable, then ROC of x of s is entire S plane except possibly excluding S equal to plus or minus infinity. Okay, right. Next, let's move on to the fifth problem, which is, fifth property, which is if x of t is a right-sided signal. Okay, if x of t is a right-sided signal, okay, if x of t is a right-sided signal, then ROC of x of s, then ROC of x of s is right side of the rightmost pole. Okay, is right side of the rightmost pole. Right side of the rightmost pole. We will explain that with an example. So, but first we should understand what do you mean by right-sided signal. Okay, still it's not over. It is right side of the rightmost pole except possibly excluding which one? S equal to plus infinity. Okay, except possibly excluding S equal to infinity. We will understand this with an example. Okay, but first you should understand what is a right-sided signal. So right-sided signal means what? The signal can start anywhere. Okay, so signal can start anywhere, but you should move in the right side, towards the right side. So note that it need not start at origin. He can start anywhere, but the signal should move towards the right side. So let's say this is some t naught. T naught can be negative or positive. Okay, but still we call that signal as a right-sided signal. So this is what? This is a right-sided signal. Okay, right-sided signal means what? It can start anywhere, but the signal should move towards right direction, or it should move towards plus infinity. Okay, so what does it say? If x of t is a right-sided signal, then ROC of x of s is right side of the rightmost pole. Okay, we will take the example. So what is the example we took? Let's take x of t to be very basic example, e power minus 3t u of t. Okay, let us take x of t to be e power minus 3t u of t. So we already know the Laplace transform of this fellow to be how much? 1 by s plus 3 with ROC real part of s greater than minus 3. Okay, if you look at the corresponding pole zero diagram, it looks like this. This is sigma j omega. How many poles this fellow has here? It has only one pole. So what is ROC we got? We got ROC to be real part of S greater than minus 3 because we have only one pole. Correct. So we have only one pole. ROC we can have two ROCs. One is real part of s greater than minus 3 or real part of s less than minus 3. But because the signal is right sided, why e power minus 3t u of t means what? The signal exists from 0 to infinity. So definitely it is an example of right sided signal, and hence what will happen? ROC should be right side of the rightmost pole. We'll take one more example so that it is clear. We take x of t to be e power minus 2t u of t. This example we have already taken. Minus e power minus 5t u of t. Okay, so for this, what is x of s we got? I am directly writing the answer. We got that to be s plus 3 by s plus 2 times s plus 5. And what is ROC we got? ROC we got it to be real part of s greater than minus 2. You can refer your notes. We have just solved this problem some time back. Okay. Yes. Now let us again draw the pole zero diagram for this. This is our pole zero diagram. We have a pole at minus 2 and we have a pole at minus 5. So if you look at the signal, because you have two u of t's, definitely the signal is a right-sided signal. Why? He will start at origin or at 0 and move towards plus infinity. And what is ROC we got here? We got ROC to be real part of s greater than minus 2. Means what? If you look at the poles, one is minus 5 and one is minus 2. What is the rightmost pole? Rightmost pole is minus 2. So, but what is ROC? ROC is right side of the rightmost pole, and that is what we have got. Correct? Real part of s greater than minus 2. Okay, that's what we mean by right sided signal. Okay, right. Okay, now let us take one more example, which is x of t to be equal to, let's say, e power minus 3 times t plus 1 multiplied with u of t plus 1. Okay, so let us take x of t to be e power minus 3 times t plus 1 multiplied with u of t plus 1. You can easily prove that this fellow will have x of s to be equal to e power s by s plus 3. That I will leave it as homework. Now what happens to ROC? Okay, so what happens to ROC? Okay, so ROC is this is again looking like e power minus 3t u of t, but ROC would be real part of s greater than minus 3. Okay, but can we include plus infinity or greater than minus 3 means he can include plus infinity also. But can we include s equal to plus infinity? No, if you replace s with plus infinity, this fellow will become infinity by infinity, and even if you do L'Hospital's rule, still that fellow would be infinite, and hence what will happen? Our x of s would be infinity, means x of s is diverging. So that should not happen, and hence what should we do? We should exclude s equal to plus infinity. So ROC is what? ROC is real part of s greater than minus 2, but we should exclude s equal to plus infinity. That's what we mean by ROC is right side of the rightmost pole, except possibly excluding s equal to plus infinity. Okay.